Question 13, Part C. The vector A is 1, 3, and the vector B is 2, negative 1. The projection of a vector x onto the vector A is k times vector A, where k is a real number. The projection of the vector x onto the vector B is p times vector B, where p is a real number. Find the vector x in terms of k and p. Define vector x with components u and v. Then the projection of vector x on vector A is given as k times vector A. Now that's given in the question. We'll call this equation number 1. But in terms of the dot product, that's equal to the dot product of vector A and vector x over the dot product of vector A to itself times vector A. We'll call this equation number 2. Now equating equations 1 and 2, we have k times vector A is equal to the dot product of vector A and vector x over the dot product of vector A to itself times vector A, dividing both sides of the equation by vector A to isolate k. We get k is equal to the dot product of vector A and vector x over the dot product of vector A to itself, where vector A is defined with components 1 and 3. Performing the dot products, we get k is equal to u plus 3v over 10, multiplying both sides of the equation by 10 to make 10k the subject. We get 10k is equal to u plus 3v. We'll call this equation number 3. Also, the projection of vector x on vector b is given as p times vector b. We'll call this equation number 4. And in terms of the dot product, the projection of vector x on vector b is equal to the dot product of vector b and vector x over the dot product of vector b to itself times vector b. We'll call this equation number 5. Equating equations 4 and 5, we have p times vector b is equal to the dot product of vector b and vector x over the dot product of vector b to itself times vector b. Dividing both sides of the equation by vector b to isolate p, we get p is equal to the dot product of vector b and vector x over the dot product of vector b to itself, where vector b is defined with components 2 and negative 1. Performing the dot products, we get p is equal to 2u minus v over 5, multiplying both sides of the equation by 5 to make 5p the subject, we get 5p is equal to 2u minus v. We'll call this equation number 6. The next step is to solve equations 3 and 6 simultaneously for u and v. The simultaneous equations are u plus 3v equals 10k and 2u minus v equals 5p. Previously they were equation numbers 3 and 6, but to make the referencing a little easier, I've relabeled those equations as equations 7 and 8. Using the elimination method, we can eliminate v to find u in terms of k and p, and we do that by taking equation number 8 and multiplying all terms by 3. So we form the following set of simultaneous equations. U plus 3v equals 10k, nothing changes there. We'll call that equation number 9. But then this equation here, equation 8, becomes 6u minus 3v equals 15p. We'll call this equation number 10. So if we take equation number 9 and add to it equation number 10, the terms involving 3v will cancel. So we get 7u is equal to 10k plus 15p. Dividing both sides of the equation by 7 to isolate u, we get u is equal to 1 over 7 times open bracket 10k plus 15p, close bracket. The next step is to eliminate u to find v in terms of k and p. And we can do that by taking equation number 7, multiplying all terms by 2. So we have a term involving 2u in both equations. And then we can eliminate u to find v in terms of k and p. And we form the following set of simultaneous equations. 2u plus 6v is equal to 20k, we'll call this equation 11. And 2u minus v equals 5p, we'll call this equation 12. So if we take equation 11 and subtract from that equation 12, we eliminate the terms involving 2u. So we have 7v is equal to 20k minus 5p. Dividing both sides of the equation by 7 to isolate v, we get v is equal to 1 over 7 times open bracket 20k minus 5p, close bracket. Now we can express vector x in terms of u and v. And that's equal to 1 over 7 times 10k plus 15p, which is our u component, and then 20k minus 5p, which is our v component. We can factorize out 5 from both the u and the v components, so vector x can be expressed as 5 over 7 times 2k plus 3p as our u component and 4k minus p as our v component.